Hello everyone, I am Radu, and for those of you which saw the workshop on Friday, you know that I am involved with IoT. You might also know that, first of all, I am a maker, and I love to do all kinds of crazy stuff like capacitive discharge pulse cutter. Even went into some high voltage tests, or even higher voltage if you wish. And yeah, why not some rockets? But someday I decided to build something more interesting, and at some point I built a network of devices which cover the planet, and that became the URAD monitor, which looks something like this. And the idea to all that was to use technology to simplify some of our tasks. And you could call that IoT automation. And the purpose for that was getting more data. So this slowly began the purpose of the project. And why would that be important? What is automated data acquisition? The idea is that we are used to various tools to get data on some parameters which we are interested in. For instance, you can just use a thermometer to get the temperature around you. Some use it to get the temperature of a bottle of Coke. It's easy to do that manually. You can just take a thermometer and do it right away. But you can use technology to do things automatically. And in this case, we get to a scenario where sensors can report data on a regular basis. What we see here are some units deployed in cities in public transportation. And the purpose for that was to monitor for various parameters related to air quality. We get things like particulate matter or carbon dioxide or formaldehyde or various other things which can impact our health in a way or another. And using IoT automation, we can have it 24/7. We can just click a button and have the data. But before we get to fancy stuff like the charts on screen, we had to take it step by step. So at the very beginning, I just built a prototype. It was with flying cables, just some test board with a few through-hole components. But the idea is that it worked. And then I decided the next step is to put it into production. Of course, this was challenging because it's one thing to just play into your lab and just do some soldering and some various tests. It's a completely different thing to scale to production. Because first you need to change your entire design to move for something which is compatible with a hobby to something which is also fitted to economical reasons. But it's doable. But we mostly talk about hardware here. Let's not underestimate the software, as everything that went into the project covered a lot of code. I think last time I checked, it was over 1 million lines of code, which of course also required a lot of time. But again, this was doable. And finally, the purpose began to show itself as the chart you've seen with the city coverage in the previous image was implemented by installing the devices in public transportation. You can see here a few buses. You can see the control panel, the electrical box. And the challenge was to find the right place for such an additional equipment. Take into account that buses, for instance, need to run the streets all the time, which is fine. But just imagine what happens when winter comes. You get temperatures below zero. You get a lot of dust. Okay, we want to measure dust. Don't get me wrong. That is fine. But at some point, it might be an issue with the circuit design. Dust gets everywhere. And combined with humidity, that can have a negative impact on the functionality itself. Also, cars and buses as well need to be washed from time to time. Now, the challenge here was that washing a car, a vehicle, is done using high pressure. So that, again, might lead to some issues if some vapors are getting to the wrong places. So it was a challenge. Luckily, I didn't have to be the guy doing this part. So sometimes this part of the job is not the best thing to do. Surely, there were some times when some maintenance was required, and that was on my shoulders, but that's a different story. And this is an animated slide. You can see it does some refresh. You see the car moving in real time in the city. So at the bottom, you see the speed. It says moving, and it's 20 and something kilometers per hour. We get all this data. And getting back to the Coke bottle, knowing that it's good for you to drink, is one thing to keep the tool in your hand and just know now and then that there are some parameters like the temperature is at that value or humidity or something like that. These are things of the past because we are moving towards the smart city buzzwords, smart homes, and so on. And what that means is we are making better use of hardware and of technology. And as you can see here, having the data 24/7 allows us to do comparisons, to understand changes better. And in case we have issues with pollution, for instance, in a city, we can pinpoint it more accurately and we can do something about it. Like if you have problem with dust on some streets in the city, we can check if there is a construction yard there and do something about it, or take into account that traffic can be redirected. And again, we can get to some solutions. So the same story goes for several other hardware devices I was involved in. These are somewhat similar in the fact that these are all IoT devices. What's different is the number of sensors they use, whether they are some portable units running on batteries, they have a screen, or they are just automated units that you install somewhere and forgot about them. The same story goes for each of these. It was interesting to go from one to another from a production point of view, like seeing how you can optimize the production of your PCBs, to see how you can do an enclosure, to see how you can test for IP protection, then to go to certifications like CE, what kind of tests are required there, what do you need to check to improve in order to have the test accepted? Because it's not exactly cheap to do such a test, and in case the iteration you are trying to push fails, you will need to adapt and submit it again. It will be cheaper, but still there's money going out the window. The story is the same. In case you have questions about these kind of things, I would be very happy to talk to you about this as well. So what's with all these things? Some of you saw enough of this at the workshop I did on Friday. You already know what IoT is. You already know what's the thing with data acquisition. The challenge here was to get the data, and we got it. It was everything we could want, like mapping it to location, or having it 24/7, or having it in real time. But it was just in 2 dimensions, meaning it was something very close to a map, where you could do it in colors or various other visualization schemes. But still, we could do more than that. So can we go 1 dimension up? Maybe something like this? Or even better? Surely just making a thing like this fly would be a way of solving the problem. So why not installing it on a rocket? Thus, with the hard drives, he would be happy to try such things, I'm sure. Just the result for us would be the same, and breaking this would be even easier than a hard drive. So instead, why not simply jump to drones? This is another buzzword. We know that they are so controllable and stable, exactly what we need. Or maybe should have DNBs for checking the foliage or the color of the leaves, would have worked perfectly. We wanted air quality measurements. This is a fail. Ouch, another one. You saw that it was out of focus. It went straight to the camera, so it's really understandable. It was run for cover, actually. It was obvious that more space was needed to get such a thing working and being able to experiment with it. Keep in mind that I'm a total noob in construction of drones, and I started like a few weeks ago, wanting to have this as a robust and functional airborne platform. I needed more space. That wasn't on purpose. Yeah, that was my feeling. I just built the thing, and I was planning to keep it without scratches, but you can't really do that. Okay, I had the space, but it wasn't enough. Some little time after, I learned more about software capabilities of these things, and what you can actually do is to take more good use of the electronics installed on these devices. You might know that there are several sensors installed there. You have things like an accelerometer, a magnetometer, you have even a barometric pressure sensor, and what you can do with all that is to make the thing use the data. So the drone is capable of leveling itself and staying in air, but I didn't know that at the beginning. So my first attempt was flying the thing fully manual. That led to what you saw. Luckily, it went on to see another day, and I was able to correct it, and it was just a few settings in the flight control software to toggle a switch and make it level itself and stay in the air. So with these things in mind, making just some configuration adjustments, there was a different result. Now that was better. So no propeller was broken, and the thing was ready to fly right away. Things can go really wrong with this kind of things. Okay, it's safety first. You can see that I went to some remote locations to do my testings. But because of the vegetation and everything, having a thing like this fall from the sky, you really risk to lose it. And it has a buzzer installed, which goes like an alarm when it crashes. But in some cases, even the buzzer got damaged, and it was a thing for finding some ways of having some redundancy on that, like being able to find it where it drops. But it was the right direction, since this flying platform could already carry a few sensors. So that was my goal, to try to make the platform itself fly, be stable, and then see what kind of sensors are fitted for flying. Actually, this is only one possible scenario which I tried to investigate with a platform like this. But as the software is so complex and the hardware on these things is so configurable, there are very many directions which should be followed for development on a flying platform like this. Take into account that you can have a platform like this take off by itself. Simply use the sensors to locate its target directions and orientation, do its job, finally return to base, recharge, and start everything all over again. It's even better than having air quality monitoring installed on buses. You don't even need a driver to get this kind of things done. And the direct application of such a technology is in controlling wildfires. Wildfires are an issue because there are places on Earth where there are high temperature and the foliage is very dry because lacking water. The Americans are having issues in California all the time with such issues, and preventing needs detection of such events. And all you need is to have an automated flying thing like what I'm showing here, do some PM 2.5 measurements. PM 2.5 is the particulate matter. That is bad for our health, but it also allows to detect smoke very efficiently. So having this work will quickly turn into a product, if you want, very similar to what was on the screen earlier. But going from hobby to production is very challenging also because reliability needs to be met. What I'm showing now is from the maker's perspective. These are the first tests. This is the working bench with all the wires flying around. This is the fun part. The things which lead to interesting new results, where we see what we can improve. Getting to production often goes closer to a business, and there's very little I could talk about there to shape it into something which is really exciting and where we can put a lot of passion in. But this part is still in its early stage. So, how to build a drone? I'm planning to share some of the things I learned because there are so many things you can do with this, and it's a lot better than just grabbing one of those fancy drones available on the market. First, I went for online shops, and I was a total noob here. I really had no idea what to choose, what to go for. I remembered I've been in CeBIT this year, and there was a show with drones, and I think that just stick to my memory, and I automatically got to buy something similar to that. But after my first tests went on, I realized what I saw there was a racing competition. So I got a racing drone, unfortunately. A thing which can fly at up to 100 kilometers per hour is not exactly easy to control. I tried, I did my best. I could possibly learn to do it better, but putting some expensive sensors on a thing like that and crashing it all over again, just think about the effort you put into building the prototype and being happy that, yes, you get the data, the sensors are fine, the drivers are fine. Heck, just think about that it's great, the code compiled, and then you ruin it in a second. That's an issue. So the drone I got was a racing drone like this one here, but I would still recommend it. Why? Simply because I crashed it so many times and it proved to be so resilient. The fact that it's small also means that it has a small impact when crashing. Part of the strength of this frame is the carbon fiber. Go for a carbon fiber drone if you want to get one. For almost $70, you get almost everything. So I think it's a fair price. At CeBIT, these things were overpriced. They were almost up to 10 times the market price. And they were, of course, used for video surveillance, there were those big monsters that even had parachute backup, which you could send away for tens of kilometers. I would probably need to get into that as well, because I would need stability, and most of all, I would need to have long range. And honestly, I am planning to try some other things. Getting to air quality for this thing was important, simply because I learned that it's best to link a hobby to something which has an ending. This doesn't mean that you need to do your homework every day, but it's best to develop a gadget which at some point maybe you could sell, because doing that will allow you to continue your day-by-day activities and have fun in doing that, and you really won't be feeling bad about it, because you know that what you do leads to a result. So back to drones. Having a drone which is very stable allows for additional applications. Just a random hint, we've seen lasers previously. Imagine you can hover a drone close to a building, like you keep it to a few tens of meters, enough for the sound of the motors not to propagate to those in that building. Now, just imagine that you would shoot a beam of laser to one of the windows, something like the nice Windows panels we have at the back of the room. What you get of that? Surely you don't want to annoy the people inside. You could use an infrared laser beam, which is invisible, and also, I've learned, safe for the eye, and use a pin photodiode and align yourself exactly 90 degrees in front of the window, enough to get your laser beam back. Anyone knows what comes out of this? The audio. The audio inside the room. So yeah, it's worth it to investigate into developing a flying platform which is hackable and controllable to a degree which can allow for exotic applications. I didn't get that far yet. I'm still at crashing level. So you could call me drone crasher now. I just did a level up and hope to do the next, just enough to keep my equipment safe. But this is pretty much you can do at this stage. So all in one, if you want to try to get yourself a platform like this, you just need a couple of things. And I encourage you to try to customize it yourself. Why? I was tempted to go into finding commercial solutions, because most of the time I say I have no time. It's a pity. We all stay here and watch fairy tales about flying things instead of maybe trying to build a time machine and then have all the time in the world to actually do something that matters. And getting a commercial existing platform would have saved me a lot of time, because I'm sure you know, at some point when something doesn't work and you are wasting like tens of hours and a lot of effort, you just feel the need to take the hammer and get it done with. Luckily, when some costs are involved, you're not doing that. You just go get some sleep and start it all over again the next day, and usually also get some good results then. I managed to evade the temptation of just getting with an existing platform, and got the frame, got the motors, got some propellers. These are just the spinning things, and they come in various shapes. The flight controller. This is interesting. It's actually a microcontroller board equipped maybe with a few sensors. The very minimum is an accelerometer, but it can have also the fancy stuff like a magnetometer or the barometric pressure sensor. The thing with the barometric pressure sensor is that you can use it instead of GPS to identify your height. because air pressure changes with altitude. And these things are so accurate that you can calculate it to a few centimeters of error, which is really good for this kind of applications. And the various controllers come with some options, but what's interesting about them is also the hardware capabilities. Most of them are ARM microcontrollers, and you get a lot of programming space and memory and everything. And this is good because for such an application to evolve, it won't be able to stay with stock firmware for a very long time. For me, as I am trained as a software developer, I'm tempted to take everything from scratch. When I get a new platform, instead of trying to learn the APIs and the interface, I always tend to go to the roots and get my hands dirty and do it my own way because it's more comfortable for me. At some point, this will be a good thing because having a drone which flies by itself would need such changes in the firmware. It's not that complicated. Just to think of some pseudocode, if you want, it's enough to do some GPS readings, is enough to have interface to the hardware, like controlling the motors, measuring the battery, so you know that you have enough juice to get home. And once you do some programming to establish the hardware control levels, where you can go like 1 meter up, go a few angles left, and things like that, then the fun begins. You can just do some scripting like you do a flight plan. Of course, such things already exist. You can do it with the open source available solutions, like the thing that was on the screen when I told you that I put the flying thing in assisted mode. That exists. That kind of control is already available. But to push it even further, to have the drone recharge itself, just imagine how convenient it would be to have a platform which is reliable and takes care of itself, which takes off, does its job, then comes back to a base and simply charges its batteries. I think I've seen such a solution, and it was really interesting. Like it was this sci-fi depot where the things were parked. The one which had to do its delivery just commanded the roof to open, then it would take off, go fly, come back for changing batteries, and the system there was to use a robotic arm to take out the battery, put it on the shelf, and take a charged battery and insert it back. And of course, there were some connectors in place where the entire thing would work just like plug and play. That's interesting, but that's hard to do. Instead, it would be much easier just to have maybe a coil at the base of the drone and then another coil at the fixed base where you want to do the recharging, to be able to use GPS for approaching the area and then some additional sensory for very precise localization of the place you want to land, and then just do wireless inductive charging, which is perfect for this scenario. So there are all these things in my head trying to transform something which now is at a prototype level, at an ideal level, something which barely works, I mean, it crashed so many times, into something which will become a platform that does these kind of things automatically. Something which you can take like a Lego piece, if you want, and build an application on top of it. And of course, as I shown you guys, the first would be in the air quality monitoring and targeting especially the wild wire things, which is currently a hot topic. It's great to keep an eye on hot topics, because all these can use technologies in so many ways to get to a solution. And again, this is about putting our hobbies into something which has a result. Okay, you don't have to see it like just selling and business, but think it instead of getting money for building new hardware. I'm sure this is great. Like, you could get all the tools. What else you would want more? So putting it together was a few hours of fun. just finding the right place for the wires, just using things like double adhesive tape, glues, and everything else you want to use. You are not limited to anything. But of course, taking into account some simple rules like making sure your high current wires are short, taking into account that it's a flying thing, so try to do some balance, try to use its equilibrium point so that it would be as stable as possible. This means that you put the things with more weight at the center, like the battery. Keep in mind that the battery, even with the current progress, it will run out in just a few minutes. So think of something which allows you to change the batteries without taking your soldering iron out on the field. So you can just do it like plug and play. Try to avoid any accidents, like all the software has big red letters that say take propellers off when you do your testing, make sure batteries off when you install the propellers and things like those. Yeah, do that because the speed is incredible. So these are toys, but they can also be dangerous. So take all this into account when building one, and it will be really fun. Now for the sensors part. Again, it was an issue of time, so I had to try to somehow reuse something of my previous work in order to get this done as quick as possible. So what I did was to go for one of the PCBs which were for one of the portable URAD monitor units. It was nice because it already had the battery, it already had the DC to DC converters to handle the battery. It already had one for 3.3 volts and one for 5 volts. The issue is that we still live in a world where we lack centralizing the specifications, not only the power outlets from one continent to another, but we still use so many bloody voltages, and this is so hard when you try to put everything on a tiny board. So this had everything in place, the voltage, the data interfaces, a big microcontroller to make space for changes and for customization. I also wanted to have a Geiger counter, so I also had 500 volts multiplier on this thing. You can see the black SMDs blocks at the center top. Those are actually high voltage diodes. Those are part of the multiplier circuit providing the high voltage. And I needed a way to get the data. So this board, let me switch it over, already had a micro SD slot, and that is really useful to make a data logger. Instead, you can just go for a cheap data logger which has the microcontroller and has the SD card on board. There are plenty available. You just add the sensors. But I had this board and I wanted to go for it. And one solution would have been to just save the data locally. That would have been easy. Just throw it on the SD card, just use it as a log file. But I wanted to do more, and so I tried to find a radio transceiver. I didn't actually use both direction communication, I only needed downlink. But what I got was the green board, which you can see it was just sticked to the main board and some jumping wires to connect it. That place there was normally occupied by an Wi-Fi module, and it was already using serial communication, so it was really easy just to throw in some wires and connect the green transceiver. I didn't know these boards, so it was like the day I got them, I had to do the first tests. If this would fail, I would simply revert to the SD card solution. The first failed, and I think the issue was that I did the soldering using some power connection without grounds, and I could feel while touching the metallic parts that there was some AC voltage getting through my soldering station. That was fine with me. I mean, you've seen that I did lots of high voltage experiments already, but I think it damaged the board. So I just switched it. Luckily, I had more. This is what I do when I get new hardware in order to see how to use it faster. And finally, I was able to use it. And it was really easy, like it's just a serial adapter. You just throw the data in and you get it to the other end. It's really wow and so easy to use. So it establishes its link automatically. It has a few milliseconds of negotiating its protocol. And then it's ready to accept your data and can do power saving and various other things, which is useful when you do a battery-based application. I didn't do any of the fancy stuff, as you can imagine. As for a prototype, I wanted to try to get a few results first. I also had an onboard GPS module. Honestly, this is taking me back to the need of getting to more customization with this platform. Why? Because I really hate to have two GPS modules on one thing, to have like 3 radio channels. This is redundant, but not needed. And all I did was to at least change different frequency for the radio modules. But what needs to be done here, of course, is to have just one single GPS unit, one single transmitter, both for remote control, also for data and telemetry, and for other communication needs. To get the code in place, this was really easy, as I used sensors which I was accustomed with. I just had to do some basic code on getting the data, I don't know, maybe transforming it to some units like micrograms per cubic meter for the dust, for PM2.5, get the temperature, get other things which were available on the board. And then just packed it in some comma-separated values format, which was fitted both for dumping it to the SD card, but also for throwing it down the line, so I wouldn't need to spend some additional time to develop a client on the other end to get the data. This can be done later, so having the data in a plain text format was better fitted for this purpose. So as you can see, I'm just forming it in a buffer, and this is done periodically in a loop. So we are reading sensors, we are sending the data, and do everything all over again. And the entire thing was just all the modules stacked together. The drone with its battery, motors, motor control, and at the top, it was the board with the sensors. There was an issue: the wind. So the wind was so high that I didn't dare to fly it with the sensor board, because I knew that if that thing will crash, it will be the last test, and it would be a delay with at least a few days until I could try it again. So what I did instead was to have the sensor boards of the drone, but linked by radio. You can see it in real time at the top. The data is coming to my computer via the radio link, and I'm getting into a terminal screen. You can see the comma-separated values. I had an issue with GPS lock on the sensor board, so the first number are zeros instead of latitude and longitude. That's too bad, because I've loved to see speed recorded here just for my curiosity. And then you can see video coming from the drone on the 3rd radio channel. As I told you, it's too much. It's really too much. We need just one radio link to the thing. You can see that I was unable to learn my configuration software properly. You normally have some settings which make it stable. What's happening here is that, also because of the wind, but not only, it did this also on good weather, the drone tries to stabilize itself. So when it senses that there's a threshold and the drone is inclined to a certain direction, it pushes the motors on that side to compensate immediately. And what you can do here is to actually configure the speed of the compensation. So this is what why it's shaking. It's doing it improperly. It's doing it too fast. You need to do it slower. So instead of it going like woo, 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 it goes nicely like woo, and stays there. And if needed, only goes back. But here, it oscillated like that. It was fine with me. I did my test. I was happy that instead, that because of the wind, I was still able to fly the thing. This was another advantage of the racing drone. So it was an excellent choice because it had the power. I could just fly it like 20% of throttle power. It's an amazing sensation to push it down and see it just jump up to the sky, and suddenly the battery alarm goes on. The power consumption is so high that the thing thinks it's running out of juice. So the purpose was reached. From this point, we have everything in place. We have the platform, it flies, well, almost, and we have the data. So the possibilities here are really very broad. We can start playing. We can start trying to build new applications on a thing like this. I wondered why these things came out so late. I mean, I saw a few done with explosion engines, you know, like in cars, trying to use gears to get enough rotation speed. But those things were too heavy, and probably only some very few constructions like those managed to get on the market or to be accessible. Drones, on the other hand, took advantage of batteries which were developed in recent years, which have higher density, so we can lower the weight. But also motors which use neodymium magnets to get enough duration. And these small steps contributed to what we have now. And it's the same with the solution that I'm proposing here. It's a small thing to take a drone and put some sensors, but the result itself and having the platform work and having the data and having the results will be something which at some point we will need. And looking back, we will think, hey, how it's possible that we were without that for so much time? So this is the impact of gradual innovation, and just making sure that the technology you put on the market is good enough, is reliable enough. So the data is not in 2 dimensions anymore. It's something like this. So imagine you have temperature readings, for instance, and you can better understand where your hotspots are and what are the causes to that. You can understand weather changes pattern if you want. You can see where certain formations take part. And having the data actually leads to knowledge. Of course, it's an issue of interpreting the data. This is another issue, like the URAD Monitor project, with its current size, has tens, hundreds of millions of entries in its database, and it's a challenge to process it and extract knowledge out of it. But ultimately, these things will be solved exactly like it happened with batteries for drones. We'll get better tools because processing power increases, as we all know. And at some point in time, we will have all the solutions in place, and it's like a puzzle. So that's about it. And these were the first steps into approaching the solution I proposed. Thank you very much, and let me know if you have any questions.
Hi. I was wondering, while listening to your lecture, I've seen that the power consumption really did no favor to you, and also damage to the equipment itself was also substantial. So have you ever thought about using, I don't know, helium balloons or something like that in combination with the drones, maybe, to make the weight of the equipment lesser? And also related to high consumption of the energy, have you ever thought about using communication that's on a, how to say, using lower frequencies and also using lower bitrate, of course, but consuming less energy, of course. Have you ever thought about those kind of things, or did you even try those?
Thank you very much. These are all valid points. A balloon would solve it. Also, you can go by putting it on a plane. The plane is more efficient, like it relies less on its engine and also uses its wings. A balloon is even better, and the balloon can be controlled as well. You can just have a few propellers on it, and you can get some orientation. For data communication, I've been involved with some deployments using LoRaWAN technology, and that is exactly what you said, low power and very wide area networks. And they use something like a few tens, hundreds of bytes per second the most. So they are very low bandwidth, and they also use very low power, and the applications for those include things running on batteries for years. With balloons, that is something that I wanted to try for a long time. Maybe I will. I did some tests with hydrogen balloons. Those were nice to fly, but also to pop. They just need a spark. But yes, for such a solution to take into account the power consumption, these optimizations would work. I'm not sure if this would be also compatible with having it as an automated solution. Remember that you need to take off and land when you want, where you want. Having it on a balloon will make it impossible, and on a plane would make it more complicated, but doable. This is why I first approached drones. Yeah, that's an option. Definitely, that would work.
Any more questions? Okay, thank you.
Thank you.